We are going to discuss the factor theorem. In this theorem, we learn that when polynomials are divided and the remainder is 0, the divisor is called a factor. What it means is, if I have fx and it is divided by an expression of ax minus b and the divisor is equal to 0, meaning there's no remainder, then ax minus b is a factor. We are now going to use the remainder theorem to prove that x minus 3 is a factor of this expression. So the question states, show that x minus 3 is a factor of this expression. So we do the same as before with the remainder theorem. We set x minus 3 equal to 0, and then we solve x. We substitute this value of x in the expression. So in the place of x, we have 3. And I see when I have substituted 3, the remainder is 0. And because the remainder is 0 when I substitute 3 into that expression, then we say x minus 3 is a factor. Notice we say x minus 3 is a factor, not x equal to 3, but the expression of x minus 3. We have found that x minus 3 is a factor of this expression. We can use that factor to factorize it. So in the previous example, we said that x minus 3 is a factor, meaning it will go perfectly into this expression with a remainder of 0. Next, we write down a standard quadratic expression. In order to factorize this expression, we need to find the values of a, b, and c. Let's start with a. In order to solve a, I take the first term in this bracket and I multiply it with the first term in the second bracket. And what I want to produce is 2x cubed. And I can see that I need to have a's value as 2. Because if I multiply x with 2x squared, I will get 2x cubed. I'm not going to find the value of b next. Our next step is to find the constant value. So if I take the constant value in the factor and I multiply it with c, I need to get to -6. So -3 times a +2 will give us a -6. So this c value then is +2. And now that we have solved a and c, we can find bx. So in order to find b, I'm going to create x squares. So I take -3 times 2x squared and x times bx. And I will create a new equation. So -3 times 2x squared is -6x squared. X times bx is plus bx squared. And this must be equal to the x squared in the expression. It's the second term in the factor multiplied with the first term in the bracket, and the first term multiplied with the second term in the bracket in order to solve b. So I have created x squared expressions. This value comes from the original expression which I am trying to factorize. I can now divide everywhere by x squared, and I'm left with -6 plus b is equals to -1. And then I can solve b. So therefore we have x minus 3 times 2x squared plus 5x plus 2. But always look if you can factorize further. The second bracket is a trinomial, and I can factorize this trinomial further. So 2x times x and 2 times 1 plus and plus. So if I multiply these two brackets out, I will get 2x squared plus 2 and plus 5x in the middle. And this is my final factorization of the original expression.